All right, hello students. Today we're going to move on with section 7.5. We're going to talk about writing and graphing inequalities. First of all, what is an inequality? This is kind of the key question. An inequality is a mathematical sentence that compares expressions. Once again, here's our words, expressions, that contains the symbols, and we should remember these from hopefully elementary school. This is a less than symbol. Remember, it means the number on the left is smaller than the number on the right. Remember, like the Pac-Man or the alligators eating the bigger number. That's how most people think of it. This one is the greater than symbol because the number on the left is greater than the number on the right. Kind of read it left to right like a normal sentence. These other two you might not recognize. This is called a less than or equal to. So kind of a less than symbol from over here with an equal to sign underneath it. And this is a greater than or equal to symbol. So the greater than symbol with an equal sign underneath it. So these are the four symbols that we're going to be working with today. Two of these we should know from elementary school, and these two kind of are new ones. But they have the same meaning, except now we have an equal sign, so it can also be the same number or represent the same situation. All right, so it's kind of talk about examples, excuse me. This is S, remember, and the symbol X, X is less than 5, so that's how we would say that. Here, P is greater than 21, and here we have an expression. We have X plus 4 is greater than or equal to 12, and of course it's okay to have these type of expressions. That, with this equal to sign, that means this side can actually equal 12. Over here, when there's not an equal sign, P cannot equal 21. It has to be greater than 21. It has to be like 22, 23, 24, 25, and so forth. Here, X cannot equal 5 because the equal to symbol is not here. It has to be less than 5. So like 4, 3, 2, 1, -1, -3, whatever, as long as it's smaller than. So it's kind of three examples, kind of what we're talking about. And this is what you'll be writing out. Very similar to how we wrote out equations. This is writing out inequalities. So like when we had equations, we have keywords. So here we have this is our less than symbol. A couple keywords, of course, is less than, is fewer than, kind of the two main ones that we talk about. This is our greater than symbol. The two kind of words we're looking at is greater than, is more than. So another word, more than. These ones over here, these are our equal to ones. So this one's less than or equal to. So just like it says, is less than or equal to. Is at most. Another one that kind of stumps people is at most. That means it can't be more than the number. So is at most means our equation's here, but it can't be bigger than the number on the right. Once again, is no more. So it can't be bigger than the number provided. So if you look at both of these, at most and is no more, it can't be more than the number provided to us. So we'll kind of talk about them as we get to them. So the left side cannot be bigger than the number provided to us on the right. The other one over here, this is greater than or equal to. Of course, that's a phrase that we use. Is at least. At least means it can't be smaller than that number. So that's why the left side, you see, is greater than, has the bigger, the alligator mouth facing the left, is greater than the number provided, or the number to the right. Is no less. So once again, it can't be smaller than the number provided. So if you ever forget the words, what they mean, or the symbols, what they mean, excuse me, here are what they mean. Of course, less than, greater than, less than or equal to, greater than or equal to. So these are the symbols and how we would say them. Excuse me. All right, so let's go ahead and go down to a problem now and see exactly how we would use this. This is very similar to writing equations out. We want to find the key words that means one of these inequalities. So write the word sentence as an inequality. So that means we're using, these of course are inequalities. So a number C is less than -4. Of course, we will see negatives. So a number C is less than. Where is less than? Here's the word less than, so we have this symbol. So the number on the left is smaller than the number on the right. Well, of course, -4 is on the right, so we have -4. And then it says a number C. Well, C just gets brought down. This is a number C. And here's your inequality. So very similar to writing equations. This was our key inequality word, is less than. So that's how we got the less than symbol. We brought down the right side, -4. We brought down the left side of C. All right, next one. A number k plus 5 is greater than or equal to. I always like to start off with the inequality. I like to find the inequality word very similar. I like to find the equation word or the equal word, because this breaks up the sentence. Is greater than or equal to. So let's go up and see where it says greater than or equal to right here. So let's go ahead and use this phrase or use that symbol. So the left side has to be greater than or equal to the right side. And the right side, of course, is 8. So that's okay by itself, 8. Here, now we have our left side or our expression, another expression. K plus. Well, this is pretty straightforward. K plus from our other lesson means the addition sign, and of course, 5. So whenever I plug in for k here, when I add it to 5, it has to be greater than or equal to 8. And we'll talk about how we find k later. We're not finding k right now. We're just talking about how we write these out based on the words. And let's go ahead and go over one more. 4 times a number q is at most. So here's the key word, is at most. This is the one that most people get stuck on. They kind of flip it around. They switch it. Remember, is at most mean the number on the left cannot be greater than the number on the right. So 16. 4 times q cannot be bigger than 16 because it's at most 16. 16 is as high as it can go. So here we go. Here's our at most. So it's a less than or equal to. So once again, the word at most means it can be 16, but it cannot be bigger. 16 is kind of our stopping point. It's kind of our ceiling, we like to call it. Now let's go ahead and write our expression out. We have 4 times, so 4 multiplication, 4 times q. And so I'm going to write it right next to each other, 4q. 4 times q is less than or equal to 16. Okay, the word at most means less than or equal to. A lot of people get this flipped around, so please don't make that mistake. All right, the next thing we need to talk about, kind of like we talked about with equations, is there are solutions. The variable has an answer or can have an answer or multiple answers. Remember, a solution of an inequality is a value. Remember, value is a number that makes the inequality true. Well, with solutions, there was only one number. X had to equal a certain number or a particular number. With inequalities here, x can be a lot of things. There's a lot of numbers that are greater than 9. X is greater than 9. And if we think about it, x can equal a whole bunch of things. X could equal 10. X could equal 11. X could equal 12. And of course, I could keep going on and on forever. X could also equal something between 10 and 9, which is 9.1. 9.2. And as you can see, I can keep doing this forever and ever and never stop. There's a whole bunch of different answers here. We call these, right here, we call all these answers a solution set. This is our solution set. There's a whole bunch of answers for x. Now, you're not going to have to write them all down. Because there's a different way of kind of showing an answer to an inequality. But you will have to be able to determine if I plug in one of these numbers for x, does it make this statement true? That's kind of what we're going to get to next. But we have to understand this is called a solution set, or all the values that make the statement true. So if I plug in any of these numbers for x, 10 is greater than 9, 11 is greater than 9, 9.1 is greater than 9. All of those things are true. So on the next section, you're going to go ahead and we're going to talk about how we determine or show if that they are true. All right, so we're going to stop the video, go ahead and move on to the second one, and we'll finish up our lesson on inequalities. All right, hello students. Let's go ahead and finish up our lesson on 7.5, writing and graphing inequalities. You're also going to have to determine if the variable or the number they give you for the variable is a solution to the inequality. So very similar to what we did with equations. We're going to tell whether the given value is a solution to the inequality. So as you can see, this is very similar to what we had with the equations, except now instead of an equal sign here, we have an inequality. So we read this, it says, x plus 1 is greater than 7. So whatever we plug in for x, we add to 1, that should be greater than 7 for it to be true. And here they're going to tell us they want x to equal 8. So like we did before, this is what x equals. Here is our x, so let's go ahead and take the x and let's go ahead and plug it in. Remember, it's not just enough to tell me yes or no. You have to show me by plugging it in. So we're going to plug in our 8. I'm going to write out the rest of the inequality. And then we're going to do the math. Well, we have to go ahead and we have to add this together. That gives me 9 greater than 7. The question is this a true statement? Is 9 greater than 7? Is the Pac-Man or the alligator mouth heading towards the bigger number? And of course, the answer is yes. This is a true statement. Okay, and this is what I expect to see. A lot of people not want to do this on when we dealt with equations, but you have to do this when we deal with inequalities as well. I want to see you plug it in. I want to see the steps being done, what you did. You added this together to get 9. What is your final result? Is this a true statement? And the answer is yes. Once again, I know these are very simplistic, but you need to show me those steps. All right, so next one, same thing. We have 7 times y. Remember, this means multiplication is less than 27. So we're going to take the 4. Remember, this is telling me that y is equal to 4. We find the y, and we plug it in. 7, I'm going to show multiplication by parentheses. Seven times 4 is less than 27. Well, 7 times 4 is 28. Less than 27. Is this a true statement? Is 28 less than 27? And the alligator mouth is pointing towards the 27, which of course is a smaller number than 28. So the answer is no. So once again, I did the work. I showed what it represents. And the answer is no. It's not a true statement. So let's go and do one more. Just make sure we have this down. Here it says A. Remember, this means division. The fraction bar means division. A divided by 5 is greater than or equal to 5. And they want A to represent 15. So let's go ahead and take a look at this. Here's A. Go ahead and plug it in. 15, 15, divided by 5. Is it greater than or equal to 5? Well, doing the division, 15 divided by 5 is 3. So we got to look at it. Is 3 greater than or equal to 5? Remember, this also could equal 5. These could be the same number. Well, the answer is no. 3 is not greater than or equal to 5, so the answer is no. And there we go. So remember, with the equal to sign down here, these could be the same number because of the equal symbol. However, they're not, and 3 is less than, not greater than, so the answer would be no. All right, now we're going to talk about how we would graph these situations. Well, remember we talked about above, we talked about the solution set. There's a whole bunch of different numbers x can be. X can be anything greater than 2. Well, instead of writing out all those numbers, what we do is we create a number line. X is greater than 2. So we make a number line. So we just have one variable, so we only need one line. We want to take our important number. Our important number is 2. How do I know it's an important number? Because it's given to us. The first thing we want to ask ourselves is, can x equal 2? If I put 2 in here for x, can x equal 2? And the answer is no, because there's not an equal to sign here. So what we do is we put our bubble. We put a bubble here. We know that x cannot equal 2, so I leave it open. It's not shaded in. There's nothing. This is not a filled-in bubble. It has to be open. And then I have to determine, well, if I make a number line, as I go to the right, the numbers increase. Right? I get 3, I get 4, and I get 5. And I always ask for 3 numbers on the right, and I always ask for 3 numbers on the left. So as the numbers go to the left, they get smaller. 1, 0. Well, what comes after 0? This is how we haven't done this since chapter 6. Well, this is -1, remember. And you will have negative numbers. As you can see down here in number 9, there are negative numbers. And the question we have to ask ourselves is, what side of 2 makes this inequality true? The right or the left? Well, if I plug in numbers from the right, 3 is greater than 2, yes. Plug in numbers, the next one, 4 is 4 greater than 2, yes. And 5, yes. So the numbers to the right make the statement true. So what we do is we shade in, or we kind of draw a little squiggly line. All these numbers will be true, or all these answers will be true. Also, all the numbers between 2 and 3, between 3 and 4, because we can't have fractions, we can't have decimals. And we only need to do 3 because we have this arrow. This arrow tells me this line goes on forever and ever. And any number to the right, of course, makes this statement true. Now, there's a little trick that I like to that we can use to help us with this, to determine which side am I shading. Well, if we look at our inequality, x is greater than 2. As long as the variable's on the left, and now this is an important piece, as long as the variable's on the left, the inequality is pointing in the direction we should shade. So this kind of makes an arrow. I need to shade that direction of 2. And this will always be true as long as the variable's on the left. So here, as you can see, it's pointed that direction, so it always gets shaded that way. So just a little trick to help you. Of course, it's all you can do is plug them in to determine which one is true. All right, so let's go and look at number 8. So same thing. We want to go ahead and we want to make our number line. We want to look at our important piece. Our important number is 3. Now, can y equal 3? Well, if we look here, once again, there is no equal sign, so y cannot equal 3. So we have to put a circle here, but it needs to be an open circle because y cannot equal 3. Then we need numbers to the right. Like I said, I always say just 3 numbers. No more, no less. Numbers to the left. And now we have to shade one direction. Well, once again, if we look at this, the variable's on the left-hand side, so of course we just simply point that direction, and this is being shaded to the left. I can always double check by plugging it in. If I plug in 2, is 2 less than 3? And the answer is yes, it is. So that's why I know that that's shading in the right direction. So let's go and look at 2 more. Well, these 2 down here now have the equal to symbol. So these 2 up top did not, and we had an open circle. We have to have an open circle because 3 cannot equal y, and over here 2 cannot equal x. So here now we have the equal sign. So let's go and see how we would shade this. Start off the same way. We make our number line. I want to underline it so you can match them up. Make sure you know. What number are we interested in? We're interested in -1. So we circle it. This is the one we're interested in. The question is, can a equal 1? And this time, yes, it can because of the equal to symbol down here. So what we're going to do is we shade in the bubble. We're going to shade it in. Yes, the -1 can be part of the answer. And then once again, we want numbers above, 1, 2, numbers below, -2, -3, and -4. And now we go ahead and we shade. Well, once again, the arrow is pointing towards the right, so we go ahead and we shade in this end. One more, number 10. So same idea. Let's go ahead and actually we're about to run out of time, so you're actually going to go ahead and you're going to stop the video. You're going to move on. We'll have a real quick video to finish this up, and you can do a couple on your own. All right, hello students. Welcome back. We're going to go over one more example 10 down here. That's going to be a little bit different. Just one more additional step that we have to do because of how it's written. If you look at this, 6 is greater than or equal to C. Well, if you look at the rest of them up here, if we looked at 7, 8, and 9, the variables are all on the left-hand side, and this is what we want. We don't want the variable on the right side. It's okay mathematically to write it like this, but it's harder to graph when it's written like this because you have to read it backwards. You actually have to read it left to right. Right to left, excuse me. So let's go ahead and rewrite this problem. Let's go ahead and put C on the left side, and let's go ahead and put 6 on the other side. So all I did was simply switch them around. But the problem is the inequality now has to stay the same. The 6 is greater than the C. So the open end still has to be facing the 6. As you can see, I kind of switched the inequality because the arrow is still pointing towards the C. The opened end is still pointing towards the 6, just like the one before, and then we put the equal sign. So these actually mean the same exact thing. The inequalities are switched around, but also the variable and the number are switched around. So these mean the same thing. This is the difference between inequalities and equations. Equations, you can switch them around, doesn't make any difference. But with inequalities, you have to switch the symbol around as well. And now we can graph. So let's go ahead and graph this. So once again, let's go ahead and make our number line. Okay, we want to go ahead and we want to put 6 in the center. And remember, we want a circle here, and because the equal to symbol, we have to fill it in. Because the answer, or C, can equal 6, this has to be filled in. Always like to take care of the bubble first because it's either going to be filled in or it's not, depending on the equal sign. And of course, we have numbers on the right. So I like to have 7. Ooh, it's a bad 7, 7, 8, and 9. Numbers on the left. Let's go ahead and go with counting down 6, 5, 4, and 3. Okay, we want to make sure we have our correct number lines. And then, like I said, another reason why we want the variable on the left-hand side is because this arrow is pointing in the direction in which we need to shade. So we need to shade to the left. If we just left it alone, the actual arrow is pointing in the opposite direction. If we look at the one that they gave us, the arrow is pointing to the right. Well, we don't want greater than, we want less than 6. So there you go. All right, so here's a couple on your own. So go ahead and pause the video. Go ahead and give these a try on your own. Remember, equal to bubbled in circle.